I'm sure you have heard lots of cases in Malaysia where fires are involved either in buildings or involving in shops when cars are set on fire or when cases where human remains are found in fire. So in all these cases, when the origins of the fire is not known, the forensic experts in terms of fire investigation come in. In Malaysia, the experts are predominantly in the fire and rescue department, bomber, and also a lot of them are also attached to insurance companies or loss adjusters, where they come in after the bomber comes in to conduct their own investigation as well, in order to release claims from insurance. So the main thing that we look at in fire investigation is the origin, where the fire started, and also what caused the fire. These two are very important to build the case surrounding the fire, as to what happened, who did it, how did it move from one place to another, and all of this is conducted scientifically and robustly to make sure that we do not miss anything or send the wrong person to prison. All right, so this analysis would involve a lot of lab analysis where we do analysis in using this instrument called chromatography, where it separates compounds based on their mass and also based on their affinity towards the instrument itself. So it produces like a fingerprint or a DNA of that particular compounds that we are analyzing. So in cases where incendiary fires are involved, incendiary here means fires that are not natural, not because of lightning, not because of accidentally someone threw their cigarette butts on a surface, but this is done with malice intent. The intent is negative. The intent is not good. So this is usually where they use ignitable liquids. These ignitable liquids are liquids such as petrol, kerosene, diesel, turpentine. You always see in the TV where they throw it into the scene and then they lit a match and then they throw it at the scene to cause the fire. So in order for us to say that this fire is incendiary, we need to find this ignitable liquid. So the analysis is done in the lab. So I hope that you enjoy this video and learn as much as possible through your kit. Thank you.
Welcome to today's fire investigation. Let's begin. So, what exactly is the purpose of a fire investigation? Well, in general, it's to determine how the fire started and why the fire behaved the way it did. Data from a fire investigation are key elements in addressing a fire problem. According to the NFPA 921, a scientific and systematic method of analysis are needed to determine the origin and cause of a fire, which is why today I will be briefly going over the basics of a fire investigation. The first point of a fire investigation is to locate the point of origin. Where, how, and why did the fire start? Imagine that you're a fire investigator and you've arrived at the scene of the crime. Essentially, the first thing that you would do is search for the general area of origin of the fire, and from there you can attempt to pinpoint the exact origin from where the fire started. Other points of a fire investigation include determining the fuel used and identifying the ignition source. When an ignition source comes into contact with fuel, it creates, boom, a fire, but not just any fire, specifically the point of origin where the fire started. And last but not least, after the fire investigator has analyzed the crime scene, they then have to determine whether it was an accidental fire or a fire that was incendiary, which means intentionally set. If the fire was classified as an accident, this means that the fire did not involve any criminal or malicious intent. However, if the fire was intentionally set, this means that the fire is considered a crime, specifically arson. So, to recap the purpose of a fire investigation, in general, it's to determine how the fire started and what exactly happened. By determining the cause of fires, fire departments can also take steps to prevent future fires. Hence, the most important reason for a fire investigation, whether the fire was accidental or not, is to prevent future fires.
Mechanism of heat transfer. There's three mechanisms of heat transfer. Firstly, conduction. Conduction is an actual physical contact between surfaces by heat application. Next, convection. Convection is the transfer of heat through circulating liquids and gases. Lastly, radiation. Radiation is the transmitting of heat energy in the form of electromagnetic wave in all directions from the fire, especially to surfaces that are facing it. Fire pattern. There's two types of fire pattern. Movement pattern and also intensity pattern. Movement pattern. Movement pattern produced by the spreading of plumes, smoke, soot, heat and combustion product. It can be used to trace the fire and smoke pattern back to the origin. There's a lot of type under the movement pattern. Firstly, V-shaped pattern. V-shaped pattern occur when there's intersection of fire plume by vertical surfaces. Circular shape pattern. Circular shape pattern usually occur on the side of tables, shelf, underneath of round tins and waste basket. Lastly, pointer and arrow pattern, or also called as beveling pattern. It is an indicator of fire direction on wood wall stud. It is displayed on a series of combustible elements such as wooden stud. Intensity pattern. Intensity pattern is indicated by the response of material and object to heat. There's a lot of type under the intensity pattern. Firstly, char. Char is a carbonaceous material that has been burned. Next, spalling. Spalling is the breakdown in surface tensile strength of concrete or brick caused by exposure to high temperature. Other than that, calcination. Calcination describes the numerous changes that occur in gypsum wallboard and plaster surfaces during a fire. Next, clean burn. Clean burn produces a clean area adjacent to area darkened by products of combustion. It produced most commonly by direct flame contact or intense radiated heat. Lastly, trailer pattern. Trailer pattern produced by ignitable liquid such as petrol, kerosene and diesel that are intentionally poured from one area to another.
Let's conclude today's fire investigation. Today, we learned about heat transfer through conduction. Good job! So let's review. Heat transfer is the transport of heat energy from one point to another. Today we learned about the mechanism of heat transfer, specifically conduction. Conduction occurs during actual physical contact between vibrating molecules upon heat application. Typically, through solids that experience a difference in temperature and thermal conductivity. Thermal inertia determines how fast the temperature rises. Conduction can only be transferred in limited quantities and is often localized.
Additionally, using the data that was obtained from the at-home lab kit experiment, a graph was constructed. The unknown time of a theoretical 6-pin dropping could then simply be determined using only the graph. Using this extrapolation method, the 6-pin was found to drop at 58 seconds. Thus, by extrapolating the graph, fire investigators can use this as a method of determining the time of damage and distance of certain items from the heat source at the fire scene.
That's all for today. Case closed.